A 5.5 earthquake struck off the coast of Oregon. On paper, it wasn't a big deal. No major damage, no injuries, no tsunami. By itself, it should have been just another small quake that people forgot about by the next day. But that isn't what happened. Within minutes, millions of people across the West Coast started asking the same question. Is this the big one? And honestly, that reaction says a lot. The real fear isn't the earthquake that just happened. It's the one that hasn't happened for more than 300 years. Beneath the Pacific Northwest, the Cascadia subduction zone has been sitting in silence, slowly building pressure the entire time. That quiet isn't comforting. If anything, it's what makes scientists the most uneasy. Because sometimes the scariest warning isn't loud at all. Sometimes it's the silence before everything changes. Yesterday, a magnitude 5.5 earthquake struck deep beneath the Pacific Ocean, about 135 miles off the southern coast of Oregon. If you only looked at the numbers, it didn't seem like much. It happened far offshore. No buildings were damaged. No one was hurt. There wasn't even a tsunami warning. The U.S. Geological Survey gave it a green alert, meaning there was no serious threat to people or infrastructure. Normally, a quake like this would barely make the news. The Earth produces thousands of earthquakes around this size every year. Most come and go without anyone outside the scientific community paying much attention. This one should have been no different, but it was. People all along the West Coast, from Northern California to Oregon, Washington, and even parts of British Columbia, immediately started asking the same question. Could this be the beginning of something bigger? Not because the shaking was unusually strong, but because of where it happened. That's the part that changed everything. This earthquake occurred just offshore from the Cascadia subduction zone, one of the most closely watched fault systems on Earth. Scientists have spent decades studying this area because they know it's capable of producing one of the largest earthquakes in North American history. So the real story isn't the magnitude, it's the location. A 5.5 earthquake, almost anywhere else, would probably be forgotten within a day. But when it happens right next to Cascadia, people naturally pay attention. They remember the warnings. They remember hearing about the big one. And they start wondering if this is the moment everyone has been waiting for. That raises the question we'll answer next. Why would such a small offshore earthquake make so many scientists stop and take a closer look? To understand why this earthquake got so much attention, you first have to understand what the Cascadia subduction zone actually is. This isn't just another fault line. It's one of the largest and most dangerous fault systems anywhere in the world. It stretches for about 700 miles, roughly 1,100 kilometers from Northern California all the way to Vancouver Island in Canada. That means it sits just offshore of 3 U.S. states and part of Western Canada. Down beneath the ocean, something is happening every single day, even though nobody can see it. A small oceanic plate called the Juan de Fuca Plate is slowly being pushed underneath the much larger North American plate. It only moves a few centimeters each year. That doesn't sound like much, but over decades, then centuries, those tiny movements add up. Here's the problem. The two plates don't slide smoothly past each other near the surface. They're locked together. The deeper parts keep moving, but the upper section stays stuck. Imagine bending a thick piece of steel. It doesn't snap right away. The pressure keeps building until it finally reaches a breaking point. That's exactly what's happening beneath the Pacific Northwest. The last time this fault fully ruptured was in the year 1700. Since then, it has spent more than 300 years quietly storing energy. No one knows exactly when that energy will finally be released. But scientists know one thing for sure. It hasn't disappeared. It's still there. And when that locked section finally gives way, it won't produce an ordinary earthquake. It could generate a magnitude 9 megathrust earthquake, thousands of times more powerful than the 5.5 quake off Oregon. The shaking could last for several minutes instead of a few seconds. Then, almost immediately, a massive tsunami could race toward the coastline, reaching some communities in as little as 15 to 20 minutes. That's why scientists don't just watch the earthquakes that happen here. They pay even closer attention to the fault that hasn't moved. Because sometimes the greatest danger isn't the movement you can feel, it's the pressure that's been building in complete silence for more than 3 centuries. After an earthquake like this, the question comes up almost immediately. Was this the big one? It's an understandable question. The quake happened right next to one of the most dangerous fault zones in North America. But based on what scientists know right now, the answer is no. Here's why. This earthquake didn't happen on the main locked section of the Cascadia subduction zone. Instead, it happened farther offshore, inside the oceanic crust of the Juan de Fuca plate. That's an important difference. Think of the whole region like a giant machine with a lot of moving parts. The earthquake we just saw came from one part of that machine knot, the part that would produce a magnitude 9 earthquake. Out there beneath the ocean, the crust is cut by smaller faults. They shift from time to time as the plate bends, twists, and pushes toward North America. Earthquakes in this area aren't unusual. Scientists see them fairly often. A Cascadia megathrust earthquake is something completely different. That happens where the Juan de Fuca plate is locked directly against the North American plate. That's the boundary that's been stuck for more than 3 centuries. When that locked section finally breaks, the entire fault can move at once. That's what creates the massive shaking and the huge tsunami everyone worries about. So, it's important not to confuse these two types of earthquakes. One happens within the oceanic plate as it deforms. The other happens along the plate boundary itself, where enormous amounts of stress have been building for hundreds of years. This week's earthquake was the first type, not the second. That should be reassuring, but only to a point. Because even though this wasn't the big one, it still happened inside the same tectonic system. The Juan de Fuca plate is the very plate that's slowly diving beneath North America. It's part of the process that keeps loading stress onto Cascadia year after year. So the earthquake wasn't the disaster people fear, but it was another reminder that the entire system is still alive. The plates are still moving. The pressure is still building. Nothing has stopped. And that's really the takeaway here. The danger didn't suddenly begin with this earthquake. It was already there, long before this happened. This quake simply reminded everyone that the forces beneath the Pacific Northwest never really stop working, even when everything above the surface feels perfectly quiet. So why does Cascadia get so much attention from scientists? Because this isn't a theory about what could happen someday. It's something that has already happened before. The last time the entire Cascadia subduction zone broke was on the night of the 26th of January 1700. Scientists estimate it was about a magnitude 9 earthquake, one of the most powerful earthquakes this region has ever produced. What's amazing is that nobody had modern instruments back then. There were no seismographs. Very few written records existed along the Pacific Northwest. So how do we know exactly when it happened? The answer comes from 3 completely different sources that all point to the same night. The first clue came from Japan. Historical records describe a tsunami crashing into the Japanese coast with no local earthquake to explain it. People were confused because the ocean suddenly flooded coastal villages, but the ground had never shaken. Years later, scientists traced that orphan tsunami back across the Pacific. The only source that fit was a massive earthquake off the coast of North America. Then came the second clue. Along parts of the Oregon and Washington coastline, researchers found entire forests of dead cedar trees. These trees weren't killed by disease or wildfire. During the earthquake, the coastline suddenly dropped, allowing saltwater to flood their roots. Tree ring studies showed they all died during the winter of 1699 to 1700, matching the Japanese records almost perfectly. The third piece of evidence came from the people who had lived there long before Europeans arrived. For generations, Native American communities passed down stories about a terrifying night when the ground shook violently and the ocean rushed inland, destroying villages along the coast. Those oral histories, shared across different tribes, tell the same story from different places. 3 completely independent sources, one from across the Pacific, one preserved in trees, one preserved in human memory. Together, they tell the same story. That gives scientists a high level of confidence that Cascadia is fully capable of producing another giant earthquake. The harder question isn't if it can happen, it's when. By studying sediment layers on the seafloor, researchers have reconstructed roughly 10,000 years of Cascadia's history. During that time, the fault has produced dozens of major earthquakes. Some ruptured only part of the fault, Others broke almost the entire margin at once. The time between those giant earthquakes isn't perfectly regular. Sometimes it's shorter, sometimes it's much longer. But the average is measured in centuries, not thousands of years. Today, it's been more than 3 centuries since the last full rupture. That doesn't mean a major earthquake is overdue in the sense that it has to happen tomorrow. Faults don't follow calendars. But it does explain why emergency planners take Cascadia so seriously. Current hazard estimates suggest there's about a 15-fun chance of a full-margin Cascadia earthquake within the next 50 years. For the southern section of the fault, the odds are even higher. These aren't scary numbers pulled from headlines. They're the same scientific estimates used to design buildings, strengthen bridges, update emergency plans, and prepare coastal communities across the Pacific Northwest. That's really why Cascadia has everyone's attention. Not because people are trying to predict the exact day it will happen, but because history has already shown what this fault can do, and the evidence tells us it will happen again someday. This is the part that makes Cascadia different from most earthquake zones. It wouldn't be over in a few seconds. If the entire fault ruptured, scientists believe the shaking could last 4 to 6 minutes. Think about that for a second. Most earthquakes people remember last maybe 15 or 20 seconds. A few feel longer because they're frightening. But 4 to 6 full minutes? That's a completely different experience. The ground wouldn't stop moving. Buildings would keep swaying, roads would crack, bridges could fail. Older homes and structures that weren't built for a massive earthquake would be especially vulnerable. Power lines, water systems, cell towers, and transportation networks could all be damaged at the same time. And that's only the first part. The bigger race would begin the moment the shaking stopped. A powerful tsunami could reach parts of the Oregon, Washington, and Northern California coastline in as little as 15 to 20 minutes. That's not much time at all. For many coastal towns, there wouldn't be hours to prepare. There wouldn't even be enough time for long traffic jams or organized evacuations. People would have to move immediately. If you're near the coast, waiting for an official warning could already be too late. Emergency plans in the Pacific Northwest are built around one simple idea. If the ground shakes hard enough, head for higher ground as fast as you can. After that, things could become even more difficult. Major highways could be broken in dozens or even hundreds of places. Landslides might block mountain roads. Some bridges may no longer be safe to cross. Entire coastal communities could be cut off from outside help for days or even weeks, depending on the damage. That's one reason emergency planners don't describe a Cascadia earthquake as just another natural disaster. They see it as a long-term emergency. Rescue crews may struggle to reach some areas. Hospitals could be overwhelmed. Power and clean water might not return quickly. Families could have to rely on whatever supplies they already have until help arrives. Now, it's important to keep this in perspective. None of this means a major earthquake is about to happen tomorrow. No scientist can honestly make that claim. But these are the exact scenarios emergency agencies prepare for because they're based on decades of research, historical evidence, and computer modeling. That's really the lesson here. The biggest danger isn't fear. It's assuming there will always be plenty of time to react. When it comes to Cascadia, the earthquake may last only a few minutes. But the impact could change life across the Pacific Northwest for months or even years. Here's something that most people never hear about. While everyone was focused on the 5.5 earthquake off Oregon, scientists were watching something else happening much deeper underground. And to them, it was just as important. Over the same week, monitoring stations picked up thousands of tiny underground signals along the Cascadia subduction zone. These weren't normal earthquakes. In fact, no one could even feel them. They're called tectonic tremors, and they happen in a completely different way. Instead of the ground suddenly snapping like it does during an earthquake, the plates slowly slide past each other over several days or even weeks. It's a quiet movement, no violent shaking, no buildings rattling, no alarms going off. The only reason we know it's happening is because modern instruments are sensitive enough to detect it. What's interesting is that this isn't a rare event. These slow-slip episodes happen on a fairly regular schedule. In northern Cascadia, they tend to occur about every 14 months. In the southern part of the fault, they can happen a little more often. So, if they're normal, Why do scientists care so much? Because these slow movements are happening deep below the part of the fault that's stuck. The deeper section keeps sliding forward. The upper section doesn't. That means every time one of these slow slip events happens, the deeper plates continue pushing against the locked section above them. Little by little, stress keeps building where the next major earthquake would eventually begin. Think about pulling on a heavy rope that's tied to a wall. The rope keeps getting tighter. You don't hear anything. You don't see much happening. But the tension keeps increasing until something finally gives. That's a pretty good way to picture Cascadia. Now, here's the important part. Scientists cannot use these tremors to predict a major earthquake. That's a common misunderstanding. These events happen regularly, and most of the time, nothing dramatic follows. No one can honestly look at this week's data and say a magnitude 9 earthquake is about to happen. Science simply isn't there yet. But these tremors do tell us something valuable. They remind us that the fault isn't dormant. It isn't inactive. It's still moving. It's still loading. The entire system is doing exactly what it's been doing for centuries. That's why researchers pay so much attention to these quiet signals, not because they announce that disaster is coming tomorrow, but because they show the engine beneath the Pacific Northwest is still running, even when everything above the surface feels completely calm. And in a place like Cascadia, sometimes the quietest signals are the ones worth listening to the most. Right after the Oregon earthquake, something else caught people's attention. It wasn't just Oregon. Over the same couple of days, earthquakes were reported in Alaska, the Philippines, China, Indonesia, Venezuela, and several other parts of the Pacific. When you see all those headlines together, it's easy to think something bigger is happening. A lot of people immediately started connecting the dots. Are these earthquakes triggering each other? Is the entire Ring of Fire waking up? Honestly, that's a natural reaction. When several earthquakes happen around the same time, it feels like the planet is building towards something. But here's where it's important to slow down. According to seismologists, there's no solid evidence that these earthquakes were directly connected. The Ring of Fire is the most active earthquake zone on Earth. It stretches for about 25,000 miles around the Pacific Ocean and contains hundreds of active faults and volcanoes. This region is constantly releasing energy. Earthquakes happen here every single day. So, when several magnitude 4 or 5 earthquakes occur within a day or two, it doesn't automatically mean they're part of one giant chain reaction. In fact, it's actually pretty normal. The Earth experiences hundreds of moderate earthquakes every week. Most people simply never hear about them because they happen in remote areas or don't cause much damage. We only notice them when several appear in the news at the same time. That's where social media can make things confusing. People start putting maps together. They draw lines between earthquakes thousands of miles apart. Before long, it sounds like the entire planet is about to crack open. The science doesn't support that. Large earthquakes can sometimes influence nearby faults, especially through aftershocks or short-range stress changes. But an earthquake off Oregon isn't causing one in the Philippines, and one in Indonesia isn't setting off another in Venezuela. Those are completely different tectonic systems, separated by enormous distances. What we're really seeing is something much less dramatic, but much more realistic. The Pacific Plate and the surrounding tectonic plates are always moving. Different sections release stress at different times. Sometimes several happen close together by coincidence. That doesn't mean they're working together. So the lesson here is simple. Don't ignore earthquake activity, but don't jump to conclusions either. A busy week on the Ring of Fire doesn't automatically mean a global disaster is about to unfold. The best approach is to follow the data, listen to the scientists, and avoid theories that go beyond what the evidence actually shows. Sometimes the truth isn't as dramatic as the headlines, but it's a lot more useful. While most of the headlines were focused on Oregon, there was another place that quietly caught the attention of seismologists: the Manila Trench, just off the western coast of the Philippines. Over the same week, a series of earthquakes showed up there. What made this unusual wasn't that there was one big earthquake followed by aftershocks. It was the opposite. There wasn't a clear main earthquake at all. Instead, scientists saw what they call an earthquake swarm, cluster of moderate earthquakes happening close together without one event leading the sequence. Now, It's important not to overreact. Most earthquake swarms come and go without turning into anything larger. That's the most common outcome, but this particular pattern is still something researchers pay close attention to. Why? Because, in rare cases, swarms like these have happened before larger earthquakes. They're not reliable warning signs, but they can be one reason scientists start watching an area more carefully. The Manila Trench isn't just any fault zone, either. It's one of the fastest-moving subduction zones in the world. The tectonic plates here are pushing together at roughly 100 millimeters every year. That may not sound fast, but in geological terms, that's a lot of motion. And just like Cascadia, that movement means stress is constantly building beneath the surface. Computer models suggest the Manila Trench is capable of producing a magnitude 9 class earthquake under the right conditions. If that ever happened, the biggest concern wouldn't only be the shaking. It would be the tsunami. Some coastal areas around the Philippines could have as little as 2 minutes before the first waves arrived. That's almost no warning at all. In many places, people would have to react immediately instead of waiting for official alerts. Still, it's important to keep this in perspective. The recent earthquake swarm does not mean a major earthquake is about to happen. Scientists are very careful about that. They don't look at a few days of activity and make predictions about tomorrow. That's simply not how earthquake science works. What they do is watch the patterns. They compare new data with what they've seen in the past. They monitor how the fault behaves over time, and if something changes, they keep studying it. So the message isn't, a disaster is coming. The message is much simpler. Pay attention, keep monitoring, and don't confuse careful observation with a prediction. That's probably the biggest lesson from both Cascadia and the Manila Trench. The goal isn't to scare people. It's to understand these fault systems as honestly as possible, without exaggerating what the science can or can't tell us today. So where does all of this leave us? The 5.5 earthquake off the Oregon coast wasn't a disaster. It didn't cause major damage. It didn't trigger a tsunami. And based on everything scientists know today, it wasn't the beginning of a magnitude 9 earthquake, but it did something important. It reminded millions of people that the Cascadia subduction zone is still there. It's still locked. It's still slowly building pressure, just like it has been for more than 300 years. That's the real story. After events like this, you'll probably see all kinds of claims online. Some people will blame solar storms. Others will talk about secret government projects or mysterious forces triggering earthquakes. Those stories spread fast because they're dramatic. The problem is, there's no scientific evidence to support them. The truth is usually much less exciting, but far more useful. Earthquakes happen because tectonic plates move. Scientists can measure that movement. They can monitor stress building along faults. What they can't do is tell us the exact day or hour a major earthquake will happen. And that's okay. Because the goal isn't to predict the future perfectly. The goal is to be ready when the future eventually arrives. If you live anywhere near an earthquake zone, the best thing you can do isn't to follow conspiracy theories or panic every time a moderate quake makes the news. It's to know your evacuation routes, have emergency supplies, and understand what to do when the ground starts shaking. In the end, that's the biggest lesson from Cascadia. The greatest danger isn't the earthquake we just felt. It's the one we haven't felt yet. For more than 3 centuries, that fault has been quietly storing energy beneath the Pacific Northwest. No headlines, no warning sirens, just silent pressure building year after year, and maybe that's the hardest part to accept. Sometimes the loudest warning isn't a violent earthquake. Sometimes it's the silence that reminds us the Earth is still moving even when we can't feel it.